Hello, I'm Mike and welcome to my DIY workshop. This video shows you how to use an electric jigsaw, and it is one of 3 videos on the subject of sawing wood. The other 2 videos show you how to use a handsaw and a manual miter saw. Right, let's have a look at a typical electric jigsaw machine. The electric motor makes the blade go up and down. The blade's teeth in most cases point upwards so that it only cuts on the upstroke. It can be used for simple straight cutting in wood or boards, or cross cutting, or if you have the right blade you can cut a big curve like that, or quite tight curves like that. There are many jigsaws available on the market, ranging from the simple budget level one where all that happens is the blade goes up and down with no other adjustment features. In the middle range you can expect to get quite a few features, which I'll now explain. First of all, you've got a simple trigger action. It's either on or off, but we have a speed control. Cutting at low speed is good for very delicate work. We also have a button here which locks the machine on. Press the trigger again to release it. This one has got a vacuum attachment so that you can put the hose of a vacuum cleaner on. I never use that because we've got a little blower here which blows the dust away from your cutting line. Now this switch here gives you variable control of an important feature called the pendulum action, sometimes called the orbital action. When the pendulum action is switched on, the blade is pushed forward on the upward cutting stroke to give you a more aggressive cut. This pencil represents the blade, so it goes to the bottom of its stroke, and then a device here pushes the blade forward against the wood and the teeth cut on the upstroke. When it gets to the top, the blade goes back like that to go down, forward to cut, back to go down. So now you can see where the pendulum description comes from. Note that it is only suitable for straight line cutting and with blades that cut on the upstroke. My jigsaw's pendulum action switch has 4 settings: 0, 1, 2 and 3, where 0 provides no pendulum action at all for fine cutting of thin wood and cutting curves. Then positions 1, 2 and 3 give you a progressive, more aggressive cutting action. The ideal setting is governed by the quality of finish you require and whether you are doing a straight or curved cut. Check your machine's handbook for advice on that. There is a small guide wheel here which presses on the back of the blade, and its pivot bearings just need a touch of oil from time to time. Now I need to talk about jigsaw blades, but first let's look at the way they are clamped into the machine. My machine is many years old and uses the old-fashioned method of tightening 2 screws here in order to clamp the blade into the machine. So I need tools. I need an Allen key or a little screwdriver for that. But more modern machines, most of them, use a quick release mechanism to change the blade, and it requires no tools. But you have to use a special jigsaw blade for that type of machine. So my machine with the clamping screws requires a blade like that called a U-shank. This part of the blade is the shank. But for the quick change blades you have to use a T-shank blade. There are different sorts of blades available, both in terms of length, width, so that's a wide one, that's a narrow one, with coarse teeth and fine teeth. You need fine teeth for finer cutting work. You need this narrow blade called a scroll blade for going round tight bends. Most jigsaw blades have the teeth pointing upwards, so they only cut on the upstroke. However, that upstroke tends to splinter the edge of the top surface, so you can buy, if you shop around, a jigsaw blade with teeth pointing downwards, so that it only cuts on the downstroke. So if you're using a blade like that, you have to switch off the pendulum action. You don't need any pendulum action if you're cutting on the downstroke. Let's just think about safety for the moment. This is a power machine with a nasty bit of jagged metal going up and down at a very fast rate, so you need to avoid personal injury, damage to your work and damage to the blade. Also, on safety, check that your power lead is in good condition and is long enough, including an extension lead if necessary, for you to reach your cutting position comfortably. Finally, have a look at your handbook that comes with the machine, because inside it'll give you some safety tips as well as tips on getting the best out of the machine. The golden rule is don't start the machine until you're in the exact correct place to start cutting. When you're part of the way along your cutting line, don't lift the machine while it is still running, because as the tip of the blade leaves the slot, it will jab on your workpiece, causing damage, and just as bad, it will bend or even break your blade. So don't lift up while it's working, and for the same reason, don't try to put the blade back in the slot while the machine is working. When you have been cutting for a minute or so and you want to change the blade, be careful, because the blade will be extremely hot. If you're cutting some white melamine board like that, you may find that the metal base plate of the jigsaw causes metal marks along there, a bit like a pencil mark. To avoid that, you can put black tape along the bottom of the base plate. Okay, let's do some example cutting. In this example, I'm using a coarse blade, can you see it? And I'm using the pendulum action on the maximum setting, which is the most aggressive cut. We're going to be cutting with the grain in a piece of softwood. Before starting the machine, always place it in exactly the right place where you want to start before switching on. From that you could see that the cutting progress was quite rapid, and I wasn't pushing the machine hard, I was just trying to guide it, but you'll see that I did go offline slightly, which is very easy to do when it's working fast like that. What I'm going to do now is, using the same blade and machine setup, I'm going to do a cut across the grain. As you can see, that was quite fast cutting, but the result is splintering. The blade cuts on the upstroke and it tends to lift the top surface wood grain, and that's the effect you get using a coarse blade, fast speed and maximum pendulum setting. I've now changed the blade to a fine tooth blade. I've switched off the pendulum action. That's the one that pushes the blade forward for the aggressive upcut, and I've also turned the speed down as well. So before I switch on the machine, fully engage the saw blade into the cutting slot. As you can see, progress is much slower because we haven't got any pendulum action to give us an aggressive cut, and I've also turned the speed down. If I turn the speed up, It's still a little faster, but it's also giving us a fairly clean edge. Now let's try it cutting across the grain. Because we weren't cutting so aggressively or so fast, and we were using a blade with a smaller teeth, we get a much better sawn edge even on the cross grain, so that's something to bear in mind. What I'm showing you here now is a piece of real veneered chipboard. Veneer is always very vulnerable to splintering and chipping like that. The blade was cutting on the upstroke, whereas the other side it's much neater. The other thing to show you is that, if you can see that, if I hold it like that, my cutting line isn't perfectly straight. It's very difficult to cut freehand with a jigsaw in a perfectly straight line. If you've got any distance to go, you really need to use a straight edge, as in the next demonstration. Next, I'm going to cut the board again, this time with the grain, and I'm going to use a straight edge. I'm simply letting the saw do the work and just making sure that the edge of the base plate is always touching this piece of wood. When coming to the end of the cut, if this piece I'm cutting off is scrap, fine, you can let it fall to the floor, but much better really to support it, stop it. And now we've got a beautiful straight edge, and it's square as well. Just like to point out how I clamped this board down on the bench. Simply used a piece of wood with a screw at each end. This next demonstration is going to show you the result of trying to force the machine. In other words, maybe the blade's a bit blunt and I'm impatient, in a hurry, and I'm forcing it, I'm really pushing hard on it. And we've got quite an extra thickness here. Whilst talking about thickness, obviously the blade on its downstroke has to be longer than the thickness of the material, so that is no good at all because the blade can't get to the bottom, and so you'll have a lot of trouble and vibration and maybe a bent and broken blade. Right, off we go. So I was really forcing the machine. Up to here I did it with no pendulum action at all. From there I did it with the pendulum action, but in both cases I was really pushing the machine hard. Finally, let me show you the results of trying to force the machine. It's very difficult to keep a straight line, and also the crooked line there doesn't match the crooked line here, because in effect, as the blade cuts, sometimes it's sloping that way and sometimes it's sloping that way. So although you might be watching your line here, who knows what's happening down here. I've got a piece of plywood clamped to the bench. I've got a curved line here which I'm going to cut along, And to do that I've got to use a scroll blade, which is a very narrow blade and with very fine teeth. And with a scroll blade, because you've got to turn round bends, we can't use the pendulum action. At the moment I'm using it at about half speed. We'll try it again in a minute, full speed. So as you can see, the speed of cut is quite slow, so now I'm going to speed up the machine to top speed. As you can see, it's a very neat cut with no splintering at all. So the high speed didn't cause any extra splintering. If you want to cut out a shape, let's say you want to put a hole in this board and this is scrap, this centerpiece will fall out and become scrap, then the thing to do is to put a starter hole inside the circle, at least 6mm diameter, so that your scroll blade will go in there before you switch the machine on. Then switch the machine on and carefully follow your circle around, and that centre part will be scrap because it'll have a hole in it. If, however, you're cutting that circle because you want this piece as a perfect circle, then you'll have to cut your starter hole on the outside before you start cutting all the way around. Then you'll get, as well as you can cut, that is, you'll get a perfect circle. Likewise, if you're needing to cut out a rectangular aperture, put a starter hole in each corner. Yes, you could get away with one hole in one corner, but when you come to each corner then you'll be struggling to get round, so it's better to cut into a straight line, break into this next hole, turn the blade and then carry on, break into the next hole, turn the blade and carry on. And then you should get a nice neat rectangle. The other two videos on the subject of sawing wood are listing on screen on the right, and if you'd like to watch one now you can just click the item. If you'd like to subscribe to my channel, you can click the circular avatar down on the left. Thanks very much for watching, and I hope you'll join me again very soon.